My name is Peter Bailey. I'm the principal engineer here at Forward Edge AI, and this is SmartBeam QRC, also called the Spectrum Slaughterhouse, particularly when it's running at high power. What we have here is a phased array beamformer using an FPGA RF SOC technology, which has 10 gigasample per second data converters, 16 of them, that's right, 10 gigasamples per second for direct RF data conversion. What we do is we have a 16 element transmit antenna. You can see right here, it's not that large, these antennas. They have very, very low distortion. And we combine the waves together using digital beamforming, sort of like if you throw multiple rocks in a pond and you get the waves to all combine together, you get a combined wavefront. And using precise control of the delays that we have only available through FPGA technology, we can control the beam in aiming wherever we want. We go a step further than that, we insert spectral nulls on the side of the beam, so that if there's anyone trying to look at the beam from the side, we can block them and remove them from the picture using AI algorithms in order to perfectly place nulls at those points where other systems are trying to read them so they get nothing. At the same time, we do STAR, simultaneous transmit and receive, because even though these arrays are right next to each other, the beam is aimed straight out. It will not interfere with the receiver due to the level of control we have over the beam shape. We use them to transmit from one device to another, 1 gigabit per second, more than 15 miles of range. This is an amazing capability for this system, and it has a packet-to-packet latency variation of less than 100 picoseconds. This makes it perfect for transmitting highly important and critical data through the system. We combine this with quantum-resistant cryptography encryption devices called the Isidore. This is another product from Forward Edge AI that's integrated into SmartBeam, which I've taken out of the case for your benefit so you can see it. This whole system integrates together into a package for many different UAVs and USVs, unmanned surface vessels, that brings an amazing communications capability not seen in many other systems before. It also, in order to make this possible, we came through the Navy STP program, one of the most amazing programs I've had the privilege of working with so far. Without them, I don't know how we would ever had this opportunity to meet all these different integrators. We even have someone already we met here who we've never heard of before, who already wants to become a part of the system themselves. We could not have done this without the amazing help of the Navy STP, and we want to thank the Navy STP program for this amazing opportunity they've given us.